Double replacement reactions. There are two types of double replacement reactions. When we study acids and bases a little later on, we'll consider the cases when they react. In this unit, we will consider the cases when the aqueous ions of two compounds react and one of the products is a solid precipitate. That reaction will only proceed if one of the products is insoluble. The reason for that is that if the products are soluble, the products will break back into the form of aqueous ions as quickly as the products form, so no reaction will proceed. Precipitation reactions involve the reaction of water-soluble ionic compounds, and that's what this aqueous means over here, to form a water-insoluble product called a precipitate. So this cloudy white stuff you see here, that's silver chloride. S means solid, which means it's a precipitate. And then we have the HNO3, which is still aqueous, that is still in solution. The ions are separate. In these reactions, the reactants are two compounds, and the products are two different compounds with the combination of elements changed as shown here. These are also called double displacement reactions. The ions appear to switch places with each other. The bond between the sodium and chlorine ions breaks, and sodium now bonds with the nitrate. So this broke, and you now have sodium nitrate. The bond between the silver and nitrate ions breaks, and the silver bonds with the chlorine ion right here. A precipitation reaction will not occur if both products are water-soluble. So over here, sodium chloride aqueous and magnesium nitrate aqueous. That means they are soluble in water. Since both of them are soluble, no reaction occurs. Some ionic compounds are water-soluble and some are not. Insoluble compounds form a precipitate. There are detailed charts on solubility, but we'll follow the approach of the College Board for its AP exam. You will only be expected to know that all sodium, potassium, ammonium, and nitrate salts are soluble in water, while other elements and compounds are not. Recall that a salt is an ionic compound consisting of a specific number of anions and cations in each formula unit, and it has a net neutral charge. Soluble salts can be easy to remember by using the first letters of their chemical names. So here we have sodium, potassium, ammonium, and nitrate. Here's some examples. Sodium chloride, sodium fluoride, sodium sulfate. Potassium chloride, potassium carbonate. Then ammonium carbonate, ammonium chloride, and ammonium nitrate. Look at this. This has two of them, right? It's got ammonium and nitrate. Then for nitrate, potassium nitrate, so we double hit on potassium, ammonium nitrate, ammonium and nitrate, and finally sodium nitrate, sodium and nitrate. Some more examples of precipitation reactions. We'll get into all the details of why reactions happen later, but note in both reactions above, chemical bonds break and reform to produce solid products. Again, that's what that little S means. That's the precipitate. Let's work an example. Predict the products of this reaction. Potassium phosphate plus magnesium chloride. The answer will be on the next slide. Potassium is going to switch from having phosphate to having chloride, and the magnesium will then group with phosphate. Next, put in the phases of the products, whether they're aqueous or solid, and balance the equation. On the left-hand side, we have two aqueous compounds that are mixed together. From our little reminder, NaKAN, what do we see there? We see that potassium is soluble, so potassium chloride will be aqueous, leaving magnesium phosphate as our solid or precipitate. And then we just put numbers in. We've done balancing before to make sure we have the same number of elements on each side. And finally, will this reaction proceed? Yes, because magnesium phosphate is a precipitate. Predict the products of this reaction. Calcium fluoride plus sodium sulfate. The answer will be on the next slide. Well, we're swapping anions and cations. So now calcium is going to go with sulfate right there. and fluorine will go with sodium. And we have to make sure the valence numbers line up so we get the right compounds written there. Next, put in the phases of the products and balance the equation. Now put in the phases of the products and balance the equation. We were given this, both of these are aqueous, and we know that sodium salts are soluble in water. So this will be aqueous, and then this will be our precipitate. And then we just balance the equation like we've done before, ensuring that the same number of elements are on each side, and that's what we have there. We put the 2 in front of the sodium fluoride. And finally, will this reaction proceed? Yes, it will. Why? Because one of the products is a precipitate, the calcium sulfate.